The galaxies were observed in the Hubble Ultra Deep Field with Hubble's Advanced Camera for Surveys and the Near Infrared and Multi-Object Spectrometer, as well as Spitzer's Infrared Array Camera and the European Southern Observatory's Infrared Spectrometer and Array Camera.
In today's Hubblecast, we have a special guest, Dr. Martin Kümmel from the European Hubble Group in Munich. Welcome, Martin.
Hello, Dr. J.
Now, you and your colleagues are responsible for the particular instrument mode on Hubble that was used by the scientists. Can you tell us a little bit about that?
The so-called GRISM mode in the Advanced Camera for Surveys spreads the different colors emitted by the galaxies into short trails. This is an example of such a GRISM. One can see the rainbow colors as the light is spread out.
So how was that used by the scientists?
Well, the analysis of these short trails allows the detection of emission from glowing hydrogen gas, giving the distance as well as an estimate of the rate at which stars are formed.
But could that not be done in a different way?
Finding and analyzing these small and faint galaxies at such great distances is at the very limit of the capabilities of the most powerful telescopes. The GRISMs on board Hubble are the only instruments that can make this kind of discovery.
By finding these 9 tiny and exceedingly faint galaxy building blocks, we followed another branch of our galactic family tree and moved a small but important step closer to understanding our cosmic roots. We already know about the existence of much more massive and therefore considerably brighter galaxies at similarly great distances. How these monsters were assembled so quickly after the Big Bang remains a real puzzle for astronomers. But that's a story for another day.
With these small galaxy building blocks, we are basically witnessing galaxy formation in action. Something that is important if we want to understand our origin on a cosmic scale. This is Dr. J, signing off for the Hubblecast. Once again, nature has surprised us beyond our wildest imagination.
The NASA ESA Hubble Space Telescope has recently revealed magnificent sections of the Veil Nebula, the shattered remains of a supernova that exploded some 5,000 to 10,000 years ago. The new Hubble images provide beautiful views of the delicate, wispy structure resulting from this cosmic cataclysm.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Travelling through time and space with our host, Dr. J, aka Dr. Joe Liske.
Welcome to the Hubblecast. Today, we will take a closer look at one of the most violent events in the universe, a supernova explosion. It is the debris from one of these cosmic explosions that we can see with unprecedented detail in these brand new images from the Hubble Space Telescope. Although we don't usually think about it, the stars twinkling in the night sky do not shine forever. How long a star lives depends on how big and heavy it is. The bigger a star, the shorter its life. Now, a star shines because of the nuclear fire burning at its center. And when a star significantly larger than our Sun runs out of fuel for this fire, it first collapses and then blows itself apart in a gigantic explosion that we call a supernova. A supernova releases so much light that it can outshine all of the stars of an entire galaxy put together. The explosion sweeps out a huge bubble in its surroundings, and at the fringe of this bubble we find the actual debris from the star as well as the material that has been swept up by the blast wave. It is this glowing, brightly colored shell of gas that we see as a nebula, and that astronomers refer to as a supernova remnant. Now, the remnant can remain visible for a very long time after the actual explosion itself has faded away.
Astronomers have pointed Hubble towards the constellation of Cygnus to observe the Veil Nebula in the wing of the Swan. Located at a distance of 1,500 light-years from Earth, the Veil Nebula, which is also known as Cygnus Loop, is one of the most spectacular supernova remnants in the sky. The entire shell spans some 3 degrees, corresponding to about 6 full moons. One of the most remarkable parts of the remnant is the so-called Witch's Broom Nebula. The bright blue star, dubbed 52 Cygni, is unrelated to the supernova explosion. It can be observed with the naked eye on a clear summer's night. The small regions captured in the new Hubble images provide stunning close-ups of the veil. Fascinating smoke-like wisps of gas are all that remain visible of what was once a Milky Way star.
Scientists estimate that the supernova explosion occurred some 5,000 to 10,000 years ago. Now what that means is that it could have been witnessed and recorded by ancient civilizations. What they would have seen is a star increasing its brightness roughly to the brightness of the crescent moon.
The intertwined rope-like filaments of gas in the Veil Nebula result from the enormous energy released as the fast-moving debris from the supernova explosion plows into the surroundings and creates a shock front. This shock, driven by debris moving at 600,000 kilometers per hour, heats the gas to millions of degrees. It is the subsequent cooling of this material that produces the brilliantly colored glows. The Hubble images of the Veil Nebula are striking examples of how processes that take place hundreds of light years away can sometimes resemble effects we see around us in our daily lives. There are similarities with the patterns formed by the interplay of light and shadow on the bottom of a swimming pool, rising smoke, or wispy cirrus clouds.
So why are astronomers interested in studying supernovae and their remnants? The reason is that they are extremely important for understanding the history of our own Milky Way. Although only a few stars per century in our galaxy end their lives in a spectacular way, these explosions are more or less directly responsible for creating all the elements in our universe that are heavier than iron. For example, all the copper, mercury, gold, iodine and lead that we see on Earth around us here today were forged in these violent explosions billions of years ago. The expanding shells of the supernova remnants eventually mixed with other material in the Milky Way, and this became the raw material for the next generation of stars and planets, including our own solar system. So the chemical elements that constitute the planets, the Earth, the plants and animals around us, and indeed our very cells, were built deep inside ancient stars and in supernova explosions. So the green in the grass and the red of our blood are in fact the colors of stardust. This is Dr. J signing off for the Hubblecast. Once again, nature has surprised us beyond our wildest imagination.
An international team of astronomers using the NASA ESA Hubble Space Telescope has discovered a ghostly ring of dark matter formed long ago during a colossal collision between two galaxy clusters. This is the first time that dark matter has been found with a distribution that differs radically from the distribution of ordinary matter.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Travelling through time and space with our host, Dr. J, aka Dr. Joe Liske.
Hello and welcome to the Hubblecast. Scientists reckon that most of the matter in the universe is something called dark matter, an unknown type of matter that neither emits nor reflects light. But does dark matter really exist? Can scientists prove it? The NASA ESA Hubble Space Telescope is helping to answer this question. In 2004, an international team of astronomers pointed Hubble towards the constellation of Pisces, the fish, to observe a galaxy cluster that goes by the telephone number of CL0024+17, and which is located 5 billion light-years away from Earth. Now, Hubble's advanced camera for surveys produced a stunning image of this cluster. The galaxies in the cluster are seen here in yellow. Analyzing the image over the last couple of years, the team discovered a ring of dark matter, seen here in blue, and realized that the position of this ring did not match at all the position of the hot gas and the galaxies in the cluster. The ring itself is 2.6 million light-years across. Now, this is the first time that dark matter has been found with a distribution that is so radically different from the distribution of the ordinary